Assalamu alaikum. This is my lab 2 of microcontroller and embedded system, and in the lab 2 task 1 we were told to assign a register 16 some specific value, and then we have to display that value on a specific port, and after that we have to add another number. That number is 25 to that previous value, and then display it on another port. So the code for that is LDI. We have loaded R17 with 255, and we have loaded R16 with the number that had to be displayed on the port. So this port B has been loaded with R17 that declares it as an output, and the port B then shows the output from R16. So the value loaded in R16 is actually shown at port B using this command. And now in another register R18, the value 25 is stored, and then a simple add command is used to add R16 and R18, and then store that added value or sum into R16, and then R16 is then shown at another port C. So let's run this code, and then I'll show you on the Proteus. Now this is the circuit that is running on the Proteus. There is nothing much to it. There are just LEDs connected to the port B and port C. So what port B does is it shows the value stored in R16, and the port C shows the value stored in R18, which actually is the sum of R16 and the number 25 as we were instructed to do. So this result is shown on the port C, and this right here ends our task 1.
अस्सलाम वालेकुम सर, ये टास्क 1 जिसमें बेसिकली बस एक रजिस्टर के अंदर एक वैल्यू स्टोर करा के फिर उसमें एडिशन करके उसको एक आउटपुट पोर्ट के ऊपर शो कराना था। तो ये उसकी प्रोटीस सिमुलेशन है। सिमुलेशन में बेसिकली और कुछ भी नहीं है, सिर्फ एलईडी शो हो रही है। ये बेसिकली इनपुट है 30, और ये फिर 30 में 25 ऐड होने के बाद 55 बनता है। ये स्टार्ट हो रहा है लेफ़्ट साइड से, और इसकी जो हार्डवेयर इम्प्लीमेंटेशन है वो इस तरह है कि ये जो लेफ़्ट साइड वाली रेड और येलो का कॉम्बिनेशन है ये रिप्रेजेंट कर रहा है 55 को, और जो राइट साइड वाला ग्रीन और रेड का कॉम्बिनेशन है ये रिप्रेजेंट कर रहा है जो 30 इनपुट था एडिशन से पहले उसको।
This is the task 2 of lab number 2, and in this task we were assigned to make a system that takes an input from a port and declares and gives the output on another port. And to do that, we have loaded a register R20 with the value 0x00, which will be used to declare the port B as an input, and the register R18 is loaded with the value 0xFF, which is used to declare the port C as an output. Now any value that comes from pin B of port B is stored in the register R19, and then that is declared at the output on port C. So this code will now be run into simulation, and let me run the code again. All these buttons are high right now. Let's turn them off. Now you can see that there is nothing going on at the port B right now. There are only 3 pins that are giving a ground using these registers. Now if I turn any of these on, the LED turns on here, and you can see that here too. And if any of these are permanently on, the LEDs at their respective positions are permanently on again. So this was the lab this was the task 2 of lab 2, and the hardware implementation will be shown to you now. Now the next code, that is task 3, might seem a bit lengthy to you, but it actually is quite simple. So what it does is the register R16 is first used to declare the DDR-C port as an output, and once the DDR-C port is declared as an output, you can use the specific bits with a specific delay of your choice to create the charging light effect. So this delay function is basically some useless commands that are actually used to waste the duty cycles of waste the calculation cycles of your CPU or the processor, and then that wastage is used to create a delay between the commands, and then the simple SBI and CBIs are used to sequentially show the output at the LEDs. Now this is shown in the simulation right here. The code is already uploaded, and we will run the code to see how it is working. First this LED is on, then this is on, then this is on, this is on, and once all 5 are on, they all go back to 0. The functioning of this code is also shown on the hardware in the next part. In this part, we were assigned with the task of comparing two numbers, and if the numbers are equal, we have to display this combination at the output, and if the numbers are not equal, then we have to toggle this output and show this combination at the output port. And to do that, we have selected some registers. R18 is stored with 0xFF, R19 is stored with 0x00, R26 is stored with 0x00. Port C is declared as an output, while port A and port B are declared as inputs. The input that we are taking at pin A is stored in R20, and from pin B is stored in R21. We are comparing using the cp command, and once that is done, and if the comparison result is 0, it will go to the value of R25 will be this, and if it's not 0, then it will be this value. And once the values are assigned to the R25 register, then the values are then stored in R26 and then displayed at the output port C, and then the circle, then the loop continues on and on and on. This is shown in the simulation right here. So these are the two numbers, and let's first upload the code. From here we go to Atmel Studio, similar application 1, and hex. Okay, so now the code is uploaded, and you can see that all the outputs are right now off. That means that both these numbers are actually equal, and we have told the code that if the two numbers are equal, then show this command, and if they're not, then show this result. So if now this number is not actually equal to this one, to make that equal, let's press this button, and once these two numbers are equal, this output is shown again. And when none of the numbers are equal, the output just toggles. The hardware implementation is shown in the next part.
और बेसिकली हार्डवेयर इम्प्लीमेंटेशन इस तरह है कि मेरे पास बटन्स की थोड़ी कमी थी. बटन्स मेरे पास 16 बटन्स पूरे मौजूद नहीं थे, तो मैंने ये किया कि हर नंबर की आखिरी 4 बिट्स को जो है मैंने 00 कर दिया कि वो इक्वल रहें. लेकिन अगर कोई भी नंबर डिफरेंट मैं पुट करता हूँ, मसलन ये जो इस साइड वाले 4 बिट्स हैं वो एक नंबर को रिप्रेजेंट कर रहे हैं, और दूसरी साइड वाले भी किसी एक नंबर को रिप्रेजेंट कर रहे हैं. अब यहाँ पे तो ये किसी भी एक बटन को दबाने से नंबर डिफरेंट हो रहा है, लेकिन अगर मैं ये भी दबा दूं और ये भी दबा दूं तो नंबर दोबारा इक्वल हो जाते हैं. सेम केस है एक और कि अगर दोनों सेकंड बिट्स को मैं दबा रहा हूं तो फिर भी नंबर इक्वल हो रहा है. थर्ड बिट्स को दबाने से भी मेरा नंबर इक्वल हो रहा है, और दोनों 4 बिट्स को दबाने से भी मेरा नंबर इक्वल हो रहा है।